Welcome to SP Smart's NEET Direct program. Today we shall discuss previous year questions given in various competitive examinations from the chapter of gravitation part first. So let's start from question first. इसमें क्या कहा है? Find the mean density of the earth. Given क्या है? R is the radius of the earth and G is acceleration to gravity. So with these two parameters, that small g is the acceleration to gravity on earth and R is the radius of the earth, you have to find the mean density of the earth. So let's start. As we know, small g is given by this formula, where m is the mass of the earth, R is the radius of the earth. As per the given question, we have to rewrite this thing as by r square, okay, because r is the radius of the earth. Now mass होता है density into volume, because density is mass upon volume, and earth being spherical 4/3 pi r cube लेना चाहिए हमें, right? So put this value in 1 and this is 1, ये value लगा दीजिए यहाँ पे. So small g will be capital G by r square और m की जगह लिख रहे हैं rho 4/3 pi r cube. alright, तो देखिए क्या कैंसिल हो सकता है, आर स्क्वायर चला गया, एक ही आर बचा यहाँ पे, तो डेंसिटी यानी इसको रखो इस तरफ, बाकी सब कुछ शिफ्ट कर दो दूसरी तरफ. सी व्हाट यू गेट नाउ, 3g by 4 pi rho r. Let's check it. So you can see that 3 pi r, no, this should be the answer, C option, 3g by 4 pi rg. 3g by 4 pi rg. Well, C is the answer to this problem. Now let's move on to question second. We have to find the depth d at which the value of small g becomes 1 by n times the value on the surface of the earth. Capital R is the radius of the earth. पूरी लंबी चौड़ी बात का मतलब है कि जो फॉर्मूला g at depth d का हमें मालूम है, इसमें हमें जी डी को पुट करना है 1 by n times g. So put this thing here. तो इससे क्या मिलेगा हमें, g upon n is g into this. ठीक है, अब देखिए इसमें क्या क्या कैंसिल हो सकता है. These two things get cancel. ये बचा 1 by n, 1 minus d by r. अब आप ऐसा करेंगे कि इसको शिफ्ट कर देंगे राइट तरफ और इसको शिफ्ट करेंगे लेफ्ट वाली तरफ. सो it becomes now d by r equal to 1 minus 1 by n. This becomes n minus 1 by n, and if you cross multiply you get this answer. Now let's check out which option is it. Well, this is the option B, n minus 1 by n into r, n minus n by n into r. So option B is the correct option for this problem. Okay, now let's move on to question third. The escape velocity on earth is 11 km per second. The escape velocity from a planet having twice the radius of the earth, तो पहले लिख लेते हैं, a radius of planet is twice the radius of the earth, and same mean density is same. Escape velocity on earth is 11 km per second. On that planet we have to find it out. Well, it's quite simple. As we know, escape velocity is given by this formula, sorry, twice gr under root. ठीक है, and further we can rewrite it as ve proportional to gr, because two constant है तो ऐसे लिख सकते हैं, since g is proportional to rho r, therefore put in above expression escape velocity is proportional to rho r into r, that means rho r square, and that means this can be written as escape velocity proportional to r root rho. Fine. Well, escape velocity of the planet would be radius of the planet proportion into square root of rho of the planet. Take ratio. Escape velocity of planet and earth, radius of planet and radius of earth, रो सेम होने की वजह से हमने देखा कि रो कट जाता है. सो ऑन द प्लैनेट escape velocity will be given by this formula. Now put the values. Radius of the planet It's twice r, it's written, given twice r by r into escape velocity of earth. These two get cancelled, twice the radius, so twice the escape velocity of the earth, which is given to be 11, so 22 kilometer per second is the escape velocity of that planet. So 22 kilometer per second. Let's check out which option is it. 22. Well, it's option A, 22 kilometer per second. So I write here A option is the correct option for this problem. Now let's move on to question 4th. Given the mass of the moon is 1 by 81 to the mass of the earth. Well, I'll write here mass of moon is equal to 1 by 81 the mass of the earth. So here I'm assuming that this earth and its mass is capital M, this is moon, mass is small m. Alright. And the corresponding radius 1 by 4th the radius of the earth. If the radius of earth is r, radius of moon is r by 4. So I can write small r, radius of the moon is 1/4 the radius of the earth. You have to find the escape velocity on the surface of moon. Well, escape velocity is given by 2gm by r square root in case of earth. In case of moon, it should be 2g small m by small r square root. Right. Now take the ratio. On moon, this is escape velocity. On earth, this is escape velocity. 2g same on gives a cancel ho raha hai. Rest, you can see this is what you get when you divide the lower term with the upper term. Alright. Now put small r equal to capital R by 4. This is what I'm going to do. Capital R divide by 4. And small m as m divided by 81. This is m divided by 81. This what I'm writing now is complete transformation in terms of capital M, capital R. Now see, these two get cancelled, these two get cancelled. This 4 will go in the numerator, this remains in denominator. 2 by 9. If you cross multiply, this is what you get. Now further, put the value of escape velocity of the earth, which is given to be 11.2 kilometer per second. 11.2 kilometer per second, right? Which comes out to be 2.48 kilometer per second. That's roughly 2.5 kilometer per second. This escape velocity on the surface of the moon. Let's check out which option is 2.5 kilometer per second. Well, option C is the correct option for this problem, right? So in this way, we have finished today's NEET Direct Programs Physics previous year questions from the chapter of gravitation. These questions are taken from various competitive exams, as you can see. Answer to question first was C, answer to question second was B, answer to question third was A, and answer to question fourth was C. That is all for today, and God bless you all.